Hello and welcome back to App for You. In this particular video, we will be discussing a very important problem from, you call it greedy or you call it drafts. Basically, it covers both the concept, right? Now, this problem is basically water connection problem. One of the most interesting problem that I have encountered so far is this water connection problem, right? Because it really took me hours, right, to understand the problem actually, right? And I will try to make it as simple and crystal clear for you in this particular video. So without further delay, let us understand what actually is this water connection problem. Water connection problem. Now let us just go through the definition that they have given about the problem, description that they have given, and then I will explain you in my words what the problem actually is. So they say that every house in the colony has at most one pipe going into it and at most one pipe going out of it, right? So basically there are houses in a colony, which is obvious, and there are two conditions. They have at most one pipe going inside it, means every house receives at most one pipe, right? So basically you can say every house receives at most one pipe and at most one pipe going out of it, and every house has at most one pipe going out of it. Means you can have houses like this which receives the pipe as well as which leaves a pipe from its house. Okay, means there can be house which has an incoming pipe and outgoing pipe. There can be a house which has only incoming pipe. There can be houses which have only outgoing pipes, or there can be basically houses with no pipes at all. This is also a possibility, right? Completely separated from the others. So that is what they have said. There is a colony in which every house has at most one pipe going inside it and at most one pipe going outside it, right? Now tanks and taps are to be installed in a manner. Now basically we have to install tanks and taps in a manner such that every house with one outgoing pipe but no incoming pipe gets a tank installed on its roof, which means that now our objective is to install what? Tanks and taps. So we have to install two things, tanks and taps. Where do you think we will install tanks? They have asked us to install tanks on those house which has only outgoing pipe. So basically among these four possibilities, only this category of houses which has only outgoing pipes will basically receive the tank, right? So basically you can see tanks are to be installed in a manner such that every house with one outgoing pipe but no incoming pipe gets a tank installed on its roof. So we will have tank in these houses which has an outgoing edge, or the point, or outgoing pipe. While what we will do, and no outgoing pipe, while houses with only an incoming pipe and no outgoing pipe gets a tap. So which of the houses will get a tap? Basically which has only incoming pipe but no outgoing pipe. So this category of houses will get a tap. So I hope this particular problem is clear, right? So there is a colony, there are many houses, four possibilities are there. Every house, either one house can have at most one incoming pipe or at most one outgoing pipe. So accordingly we have four possibilities. Either a house has both incoming and outgoing pipe, or a house has only outgoing pipe, or a house has only incoming pipe, or a house has neither an incoming pipe nor an outgoing pipe, right? These are the four possibilities, and they have strictly mentioned that we will insert tank in only those houses which has an outgoing pipe, and we will install tank only in those houses which has outgoing pipes, and we will install these taps in only those houses which has an incoming pipe. Got the point? We have to basically return what? Let me explain you. So we have to basically return how many tanks and taps do we have to require for this particular purpose, how many tanks and taps we need. Okay, this is the first of all the basic part that we have to discuss. How many tanks and tap we have to, basically how many tank and taps we require, and what do we need. Find the efficient way for the construction of the network of pipes, and we have to find the efficient way for basically construction of the network of pipes. So what does that mean? So just let me copy this. So I'll show you the explanation. This is the input, this is the output. Let me now increase the size of the screen. So now let us see an example and understand the problem. So basically the problem has two things as input, right? One of the input is n, which is nothing but number of houses in the colony, right? This is the number of houses. So we have 9 houses in the colony. P indicates the number of pipes. So number of pipes. This indicates the number of pipes in the colony. And what does this indicate? The connection of the pipe, the information about the connection of each pipe. You can see P is equal to 6, so there are information about 6 pipes. So this is the first pipe from 7 to 4, second pipe is from 5 to 9, third pipe is from 4 to 6, fourth pipe is from 2 to 8, fifth pipe is from 9 to 7, and sixth pipe is basically from 3 to 1. So that is why the source pipe, the destination, the source to destination, this is the direction of the pipes, okay? And this information is given, and this basically array D represents nothing but the diameter of the pipe in the corresponding case. For example, for the pipe that moves from 7 to 4, from house number 7 to house number 4 has a diameter of 98, and if you consider the last one, the pipe that moves from house number 3 to house number 1 has a diameter of 66. So these informations are basically stored in these 3 arrays. So what should I do? Now let us now basically create this array. So let me just create this array, array A, array B, and an array D, right? So these 3 arrays are already here. Now we have A, B, and D done. So let us now fill the array with elements. So what are the elements? So basically we know the elements here are 7, 5, 4, 2, 9, 3, right? Considering the destination, we have 4, 9, 6, 8, 7, and 1, right? Now a pipe is moving from 7 to 4, 5 to 9, 4 to 6, 2 to 8, 9 to 7, 3 to 1. 6 pipes. I hope you can understand. Let me number the index: 0, 1, 2, 3, 4, and 5. Okay. And this D represents nothing but the diameter. So diameter of the first pipe is basically 98, 72, 10, 22, 17, 66. This is 17, right? Cool. So these informations are given to us, right? Now what we need to do is basically, let's try to visualize this in a graph. So things will become very, very interesting now. Now if we try to visualize this thing in a graph, what will happen? So let me draw a graph. For that particular reason, I'll be using a good color. Let us use brown, orange, fine. What are the vertices? We have 1. Let's use yellow only. That's bright. Okay. So we have colony house number 1, house number 2, house number 3, house number 4, house number 5, house number 6, house number 7, house number 8, and house number 9. Suppose each house is nothing but the vertices of a graph. Done. Next thing is, we will draw the edge. Now you see, this information is basically giving me the idea of the edge. So basically from 7 to 4 I have an edge. So I have an edge from 7 to 4. So 7 to 4 I have an edge. So 7 to 4 I will be drawing an edge. Done. Next thing is 5 to 9 I have another edge. So 5 to 9 I will be drawing an edge. So basically this is 5, this is 9. So suppose I will be drawing like this, okay, outside. So 5 to 9, the direction is from 5 to 9. 4 to 6 I have an edge. So 4 to 6 I have an edge. 2 to 8 I have an edge. So basically 2 to 8 I have an edge. 9 to 7 I have an edge. So basically from 9 to vertex 7 I have an edge. So basically let us draw like this, no problem. 9 to 7 I have an edge. 3 to 1 I have an edge. 3 to 1 I have an edge. Got the point? This is the equivalent graph that is present. So you can basically visualize how the houses in the colony are connected to each other. Now basically the question says that how many tanks and how many taps will be required. So remember, I explained you four types of houses. I showed you 4 types of houses. A house that has an incoming edge and an outgoing edge, means an incoming pipe and an outgoing pipe. A house that has only incoming pipe, a house that has only outgoing pipe, and a house that has no pipe. And the question said that for those houses which has an outgoing pipe, we have to install their tank. For those houses which has only incoming pipe, we have to install what? Tap. What the point? So now you can easily conclude from this graph, if the information of the incoming and outgoing edges are known, and those informations are really present, actually present in this array only, right? Then you can find out that this node 3, which has only outgoing edge, will have a tank. Got it? This node 2, which has only outgoing edge, will have a tank. And this node 5, which also has only outgoing edge, will have a tank. What the point? And which houses will have taps? So basically the last terminal of this particular pipe will have tap. For example, from this is a tank, so water will flow from 3 to 1, and you see no more edges are coming out of this. So this node has only incoming edge. So for incoming edge we put a tap. So where do you think we will put taps? So we will put taps in this house. We will put tap, see, from 2 to 8. So tank is put here, this water will extend till 8 only. We will put tap here. And where do you think we will put one more tap? Now since I am putting the tank in house number 5, so from house number 5 the flow will be maintained from 5 to 9. Now you see 9 has an incoming edge as well as an outgoing edge. So basically it comes in this category and we don't have to do anything. Move ahead. 7 again in that category. 4 also in that category. 6 is the node which has only incoming edge but no outgoing edge. So taps will be here. So what is the information? Now you see the output will be 3. Why? Because I need 3 tanks and 3 taps. 3 tanks and 3 taps. What the point? Next thing is, they have asked us to basically print, right, the destination, right, from which point to which point, what is the starting point and what is the ending point of each pipeline. What is the point? And the minimum age in that pipeline we have to print. So basically, how many pipelines do you think you have here? I mean, how many independent connections you have here, right? How many connections you have here? You can see this 3 and 1 is a connected graph, right? This is a connected graph and it is a component separate, right? It is separate from the rest of the graph, but itself 3 and 1 is connected. Similarly, 2 and 1, now see 3 and 1, basically 3 and 1 are connected and they are a component of this graph. 2 and 1 is also connected component of this graph, right? Similarly, I have the third component that starts with 5 and ends at 6. So there are 3 components, 2 to 8, 3 to 1, 5 to 6. How do you find this? So I hope you got the idea. Basically we are going to implement Dfs Traversal. So we are going to use depth first search to basically find out the source and the destination of each connected component, right? You can see 3 to 1, 3 to 1, 5 ends at 6, so I have this component here. 2 starts at 2, ends at 8, I have this component here, right? And what are these value indicates? This value indicates the minimum value edge in that path. So from 2 to 8, the minimum value edge is nothing but this edge only, one edge only. So 28, 22, 22, right? Let me erase this. I hope you got the point. 22, so 22 here. Next, from 3 to 1. So from 3 to 1, I have only one edge, and 3 to 1 value is only 66. So only 66 is the minimum. 5 to 6. Now here there are multiple edges between the from 5 to 6, right? Which is the minimum edge present in 5 to 6? The minimum edge present from 5 to 6 is basically this edge, 4 to 6, 10. This path has minimum diameter. So I have to print the value of the minimum diameter in the path. What the point? This is what we have to basically implement through a code. Points to note. What are the challenges that we have to ensure? We have to face basically. Very first thing, we know that how will we understand that this node receives only, this node has only outgoing edge, and how will we understand that this node has only incoming edge? What the point? We should have a mechanism to understand how that this node is, that a particular node is has only incoming edges or outgoing edges. So we should have a mechanism for that, and we will try to see that in code, right? The mechanism, how to understand whether a node has incoming edge only or an outgoing edge only, or both of them is present. What the point? So yes, now we will finally jump into the coding part. So the problem description I hope is crystal clear. Now understanding the problem will become very, very easy. So let us hope for the best and start the coding. So alright, let us now start coding the particular problem. So before that, Now, in order to simplify the things, okay, what I would like to do is basically I would like to consider that the element, that the information that they have been given, that they have basically provided, right, are stored in the form of matrix. So basically I will assume that we have a matrix, and let me just write it. So I'll be assuming that we have got a matrix and we have elements there like 7, 4, 98, got it, 5, 9, 72, 4, 6, 10, 2, 8, 22, 9, 7, 17, right, and 3, 1, 66, right. So assuming that we are provided with this matrix, right, wherein these are nothing but the pipe numbers 0, 1, 2, 3, 4 and 5, right. So we will first of all, as I said in the discussion, that we have to ensure and tackle this particular problem of how to decide whether a node has only incoming or only outgoing edge. How do we decide those things? So in order to decide those things, I will be using two arrays, right. I'll be using two arrays. What will be the arrays? Basically, let me make a global declaration of those arrays. So now how many nodes are there? So total, we know that number of nodes is equal to number of houses, right. Number of nodes is equal to nothing but number of houses in the colony, right. And number of houses given in the question was 9. This particular information was basically given. So we will be declaring two arrays, and that they will be named as, suppose for convenience, ith pipe ends at. Okay, this is the name. Let it have 9. Let its size be 9, which means that this particular array will give me the information about a particular pipe which starts from a house, will end at which house. Got it? And next thing is ith pipe receives from which house. So basically this information will give me a particular house has received a pipe from which house, and first one will give me the information about a particular pipe has basically is sending pipe to which house. So to make it more clear, I have two arrays and I will be writing them here. So this is the array, first one, second one, right, and this is one more house, that is diameter, that will give me the diameter. So let it be diameter of same thing 9, right. So let me just erase this. Alright, fine. So I have declared three arrays and let me name them here. So this basically means ith pipe ends at. So ith pipe ends at, ith pipe receives from, and this is nothing but diameter. Now how do we deal with this? Why I am saying ith? Because the size of this is basically nothing but 9. So which means 0th house, first, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, I think it's clumsy. Let me just write it more properly. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So this is nothing but the house number. Okay, so the index are nothing but house number. So when I say for this particular point ith pipe ends at, means if a pipe is starting from house number 0, where will it end? Okay, this particular pipe ends to which house? That value will be here, and this 0th house has received the pipe from which house? That information will be here. That is why I am saying ith pipe receives from, means house number 0 received pipe from which house? House number 0 received pipe from is sending pipe to which house. So this pipe is basically sending to which house, and this house has received pipe from which house. Those information are present in these two array. I hope this is clear. Ith pipe ends at means the pipe moving from this house will end at which house. Okay, and ith pipe receives from means this house has received pipe from which house. So this is basically going to give me the information of outgoing edge, and this is going to give me the information of incoming edge. Got the point? Fine. So that now initially all of these should be initialized to 0. Initially all of them will be 0, right? So 0 0 0. We have to initialize this. Now how will we do this initialization? We will do this only when we will write the code. So don't do this now. Right now I'm just doing a global declaration of these three things. Done. One more information. Our n and p are also globally defined. Right? So now I have just assumed that okay, n value will be 9. That is why I'm giving 9. Otherwise you can write here n after receiving the input. So in ith pipe ends at 9, and ith pipe receives from 9. Diameter is also 9. Done. Now we will basically come inside the main function, and here basically what we are going to do is declare the array. Now which array? This particular array, right? This particular array needs to be defined here. So we will do the definition of the array. So for defining the array, now since I have declared n and p globally, so I know the value of them will be n equal to 9 and p equal to 6, right? Because 9 houses and 6 pipes are there. Now since I have already created these three arrays, now I have to initialize them initially to 0, right? There are multiple ways of doing it. You can just use for loop and then just initialize each of them to 0, or better I will just use memset, right? As basically they have also explained in the article, and it was very good. So you can use memset, and the name of the array is nothing but ith pipe ends at, right? This is the name of the array, comma, I want to fill them with 0, and how many bytes? Basically size of the name of this array. Done. Fine. Similarly, I will basically fill all the remaining arrays with 0. So which arrays? This array, ith pipe receives from. What is the name? Receives from, right? So receives from, and this will also be remaining same. The size is same, so it doesn't matter, but still for sake of perfectness I am just going to write them separately. Diameter. So memset of which array? Memset the array diameter 0, fill with 0, and size of what? Size of diameter, size of the array. Got it? So this will basically help me to initialize all the values with 0, right? So they all are 0 now. This will play a significant role later on. So I am explaining the approach they have mentioned in the article, right? And later on in further videos I will try to come up with a simple approach if any alternative approach also exists, right? This is one of the approach that they have discussed in the article, and I have gone through several articles to understand this in depth, and I found that okay, this is quite easy to understand, so I have picked up this particular approach. Done. So we see that we have basically declared all these three pipes with 0. Now what next? So basically now we should declare the array. So the array that I'm going to declare is integer array, and 3 columns will be there, right? Because you can see there are 3 columns. I'm not defining the number of rows. You can define, no problem, but there are 3 columns, right? So what we are going to do is equal to what? They are basically equal to, let me write the values, 7 4 and 98. So 7 4 and 98. So 7 comma 4 comma 98. Done. Comma, what's next? We basically have 5 9 72. 5 comma 9 comma 72, right? Comma, what do we have next? 4 comma 6 comma 10, comma 2 comma 8 comma 22. 2 comma 8 comma 22, comma 9 comma 7 comma 17. 9 comma 7 comma 17, right? and finally we have 3 comma 1 comma 66. 3 comma 1 comma 66, right? I'll be very fast now, and I'll be just closing this entire thing and put a semicolon at the end. That's it. So the declaration of this array is complete, right? So I have basically defined this array. The declaration is complete. All right, let's make it easy to understand. Yeah, here it is. Cool. So the declaration of the array is ready. 7498, 5972, 4610, 2822, 9717 and 3166. What next? Now we will basically suppose call a function and pass this array there, right, to solve it. Now let us define that particular function. Alright, so we will define that particular function now. So we don't require this now, let us delete it, right, and delete this also, we don't need this. Fine. So we are going to now define this function. Which function? Now this will also return, okay? After this is complete, it will return, because this type, the main function is integer type, so it has got to return something. So return 0. Now when a function is called, what will happen? I have a function void function. It is going to receive the array. Which array? Integer array. This is the dimension of the array, right? It is going to receive. Inside this function, I will basically consider a variable I equal to 0, right? What I'm going to do now? Now I will basically, it's my duty now. Now this is what I have to perform. Now we basically have to fill these arrays with their appropriate values. Got the point? So we basically have to fill these arrays with their appropriate values. It's time. So how do we do so? Now basically what we are going to do, we are going to run a loop from I equal to 0. Okay. So I'll say for I is equal to 0, I less than p, the number of pipes that I have, right? I plus plus, and each time for each pipe. So basically I am using this to refer to this array. Getting the point? To refer to this input array that we have provided. This array. I equal to 0 to p. You can see 0 to less than p means still 5. I'm going to refer, and I am going to pick each of them, and going to put them here. How to do so? You see. Right now I'll basically declare variables, some more variables, supporting variables. Suppose comma p, comma q, comma h. Okay. So what I'm going to do is basically I is equal to 0, I less than b, I plus plus. So refer to the first row, array of I, right? Refer to the first row, first column, that is 0. Refer to the ith, sorry, not first row, ith row 0, first column, ith row, first column, one column, and similarly array of ith row and second column. What the point? So each of these will be stored in a variable. P is equal to this, suppose. Q is equal to this, suppose. H is equal to this, suppose. Okay. P is equal to this, Q equal to this, H is equal to this. Now what to do next? Next what we have to do is basically we have to fill these arrays. What is the name of this array? Ith pipe ends at. Control C. So what do we do for that? Now what we are going to do basically is, for each pipe that you have picked up, right? Now I am going to say, let me erase this now. Okay, I think a P we have already used above, right? So we cannot use P here right now. So let us use Q, H, comma T, right? So this will also be equal to Q, H, let it be T, right? So now what should we do? We will write index of, not index, sorry, this ith pipe ends at, Control C, Control V. Ith pipe ends at Q is equal to what? Now why Q? Because you see, initially I equal to 0, I am referring to which row? Now I'll start filling the values. Okay. So initially I is equal to 0, so it is pointing to which row? So let me just use a good color, pink suppose. Nah. So I is pointing to this right now, right? Q equal to array of is of 0 means Q will point to this 7. So when Q is pointing to this 7, what does it mean? It means that I am pointing to house number 7, right? So considering house number 7, I will come here in ith pipe ends at. That is why I am writing ith pipe ends at Q is equal to. Now what is the information? It says that the pipe that moves from 7 is ending at which house? Pipe that is moving from 7 is actually ending at 4. And that 4 value is basically stored here, right? You see 7, 4, 98. So Q stores 7, H stores 4, T stores 98. So I should basically update this array. Now how to update this array? Ith pipe ends at Q means the value at this position Q, that is house number 7. You should put here what? The value of H. So H is nothing but 4. So what does this mean? Now see, this basically indicates 7th house, the pipe moving from 7th house ends at 4th house. So information filled. What the point? So is equal to what we should write? Equal to H. Similarly, what we should write again? We should also write the equivalent cost, right? The equivalent cost. So how do we write the equivalent cost? Distance array of Q is equal to how much? Is equal to basically the value stored in T. The value stored in T. So basically simultaneously this will be updated. What is the distance here? Distance is nothing but 98. So updated here 98. Got the point? Now this should also be updated, right? Not now. Now what should be updated? Basically we should see what does this mean is there is a node 7 and a vertex is visiting from nodes, edge is visiting from 7, pipe is visiting from 7 to 4. So we basically updated this information that there was a pipe moving from 7 by writing this, by writing 4 here, which means up 7 from 7 a pipe is moving from 7 to 4, right? The weight of the pipe also we kept track in this array, diameter 98. Now we should also update the information in house number 4 that it has actually received some pipe from house number 7. Now how do we do so? So we should basically write ith pipe receives from of H is equal to Q. Got the point? Which means now this information we have updated that from house 7 pipe is moving to 4 by writing here. Now from house number 4 is receiving from 7. How to write that information? We will write that information in this array. Ith this pipe receives from. So house number 4 means this one receives from which house? 7. So I will write 7 here. I hope this point is clear. Now next time I will basically move to which house? Now I will basically move to the next house, right? So just let us rub this. I comes to this particular row now. Now what is the information? This is Q, this is H, this is T. So Q now will be 5, H will be 9 and T is 72. So ith pipe ends at Q is equal to H, means ith pipe ends at 5 is equal to 9. So at 5 pipe ends at 9. So update this information here. Got the point? So I am updating this information that from house number 5 a pipe ends at 9, house number 9 means a pipe is going from 5 to 9. Done. At the same time I should update the weight. What is the weight of this pipe? 72. So that should be updated in the this particular column only here 72. And now since I know that from 5 a pipe is going to 9, this information I have stored in this first array. How to store this information? That 9 is receiving an edge by storing it in this array. So 9th house basically here has received a value from 5, right? I had received connection from 5. This will be 5 here. What the point? So this particular value is also filled. Likewise, you will basically go on filling the entire row. Now this row I am here. This work is done. This time 4, 6, 10. So 4, 6, 10. House number 4 ends pipe at 6. So house number 4 here, okay, ends pipe at house number 6. House number 4 ends pipe at 6. And house number 6 then receives pipe from 4. So this update information should be kept here. right? And what is the cost of this pipe? The cost of this pipe is nothing but how much? 10. So 10 should be put here. Done. This row also task is complete. Now I moves ahead to this row 2, 8, 22. So what happens is basically this time your Q is 2, H is 8, and this is 22. So considering this, what happens is basically you have to fill. So house number 2 pipe ends at 8. House number 2 pipe ends at 8. So fill 8 here. So fill this with 8. Done. And house number 8 receives pipe from 2. This information should be updated here. House number 8 receives pipe from 2. Update this information, not here, sorry. This is 0 only. What am I doing? Wait a minute here. House number 8 receives pipe from 2. That information will be present here. Done. And the cost of this pipe, house number 2 basically, will be 22. From house number 2, the pipe that is moving to 8, the cost is 22. Writing here. Done. Next row now. When we are in the next row, we are basically pointing to this row. 9, 7 and 17. So 9, 7, 17. So house number 9 pipe is moving to 7. House number 9 pipe is moving to which house? 7. So pipe ends at 7 right here. House number 7. Now what is the cost of this pipe? Cost of this pipe is 17. So I'll basically update 17 now. 17. And house number 7 has received the pipe. So basically I should update that information also. So house number 7 has received the pipe from which house? House number 9. So update this information here. Done. Next we have house number this 5. So not 5, sorry, we are in this row, right? 5th row. Now 5th pipe is basically moving from 3rd house to 1st house. 3rd house, 1st house, cost is 66. So 3rd house, the pipe moves till the 1st house. So house number 1, cost of the pipe is 66. Update here. And house 1 is receiving the pipe from 3. So that information should be updated here. House 1 received pipe from 3. Right? That's it. Our important, very important table is created. Now this table is going to help me in doing Dfs traversal. Right? So this is the most important part that we have covered right now. This part, the filling of this information. How do you keep track of the nodes with incoming and outgoing edges? Because our Dfs traversal will start from only that node which will have a tank. And which node will have a tank? Only those nodes which has only outgoing edges. And how do you understand whether a node has an only outgoing edges? So a node will have an only outgoing edge if it has not received a pipe from any edge, any node. So that information how will understand? You see pipe house number 0. House number 0 has not received pipe from any house. House number 1 does not receive pipe from any house. Right? And how do you understand? Sorry, how do you understand whether a node will be having a tank? If it has only outgoing edges, right? If it has only outgoing edges and no incoming edges. So outgoing edges means, see house number 2 has an outgoing edge because it's sending a pipe to house number 8, but it has not received a pipe from anyone. 0. House number 3 will not be considered because it has an incoming edge as well as an outgoing edge. This is outgoing edge, this is incoming edge. So we'll consider this house number 2. House number 3 also will be considered because you see it is sending pipe to house number 1 and it has not received pipe from anyone. House number 5 will also be considered because it has sent a pipe to house number 9 and is also receiving the pipe from house number from no house. Getting the point? Alright. So now this is enough to understand which house, basically which nodes will be considered for the setting up the tanks. Now let us implement the DFS. So this should actually increment every time I++. Now these informations basically I am going to declare two vectors above, right? I am going to declare two vectors. So vector, I'll explain why I am using those vectors. Vector int a, vector int b, and vector int c. right? Now you remember in the output we have to print those things, right? The source node, the destination node, and the cost of the minimum pipe between them, right? That thing we have to print. So for that we are using three vectors, right, to push the informations. Fine. So now we are going to basically implement the Dfs traversal. So how will we do so? Now you see, let me just rub it. This part is clear. Alright, so the vectors that I declared above, now it's time to use them. So before that, let me just clear them. A dot clear, b dot clear, to clear any garbage value, clear clear. Done. Now here I am just using this particular function. I have right now just copied and pasted. Now let me explain how this is working. So now, since we have already prepared this array, now since this array is already prepared, now how do you use it? So for that particular reason, what we are going to do is basically start traversing from j equal to 1 to j less than equal to n. What is n? N is nothing but the number of houses, right? The number of houses. And now means I am basically traversing this, okay, 0 to n. Let me erase this thing now, not required. Okay, so what is happening? Basically we are traversing all the houses 0 to n. Okay, house number 1 to n, sorry, because house number starts from 1 to n. Okay, 1 to n, this will be used. Now what we are doing is basically let me do one thing. Okay, so I think it would be a good idea to basically let me see. Yeah, the pipe ends at pipe receives from, let us increase the size of this. Yes, actually I have declared the size of these arrays to be 9, and accordingly it will be starting from 0 till 8, but I need a house number 9 also. So for that particular reason I think it's good to declare the size as 10, right? One more. So that is why I will be declaring here as 10, right? Array of 10, array of 10, and 10 here also. Fine. So what next? Now this issue is solved. So basically what we are going to do now is, I have basically used this code. Now you just see what this code is actually doing. So this particular problem here is going to, now this particular code, block of code is going to traverse all the houses, okay, from beginning till end, from the first house till the last house, and it is this line will basically check whether that particular house receives from some house or not. So basically if I found out that a node, that is a house, is not receiving pipe from any house, then its value will be 0. Like I said you, like this house number 1 is not receiving from any house, so it is equal to 0. And at the same time it should basically send pipe to some house. Means basically there should be a house which has some outgoing edge and no incoming edge. So what does that mean? It means that the outgoing value, which means the value corresponding to that house in this array, should be present, but in this array it should be 0. Like consider this particular point 2, house number 2. So house number 2, ith pipe receives from j is equal to 0. Is it true? So basically this 22 should be updated here, right? This is diameter, this is 0. So see, second pipe, the house number 2, basically house number 2 has not received pipe from any house, which means there is no incoming edge, but it has sent pipe to house number 8, so there is an outgoing edge. So we should consider this pipe, this house as reference. This is true, and this is also returned as true by this house number 2, because its ith pipe sends at is equal to 8, which is true, and ith pipe receives from j is equal to 0, which is also true. Both true, so it will come inside and basically perform the Dfs traversal, right? Now what I am doing is basically, you see, I should declare this variable answer globally. So globally here I will be declaring it integer answer. It will store the cost, right, the minimum path cost, and hence I am just assigning it some maximum value initially. You can write int max here, no problem. Some maximum value in the beginning I am assigning here. Now what is happening is, I am calling DFS of J. So what is happening is basically, you see, to understand this, we should basically rub this and let us just draw the graph. So graph looks like, I'll be very quick here. So we have house number 1, house number 2, house number 3, 4, 5, 6, 7, 8 and 9, right? And I'll be using some bright color, suppose white, to indicate the edges. So now there is an edge from which house? From house number 7 to 4. So basically this information we know, we have it. There is an edge from 5 to 9. 5 to 9, so this information is also there with us. 4 to 6 there is an edge. This information is also with us. 2 to 8 there is an edge. 2 to 8 there is an edge. This information is with us. 9 to 7 there is an edge. So 9 to 7, so basically this one, yes, it is here with us. And 3 to 1, so basically this one. Fine. So just now, by using this particular block of code, what we are finding out? We are finding out the node which has only outgoing edge. So which are the nodes that will be detected? Node number 2 will be detected, which has only outgoing edge but no incoming edge. Node number 3 will be detected, which has only outgoing edge but no incoming edge. And node number 5 will be detected, which has only outgoing edge but no incoming edge. So there will be a DFS call on each of these nodes, starting from 2, starting from 3, starting from 5. So once we start a DFS call from this node, what we will do? The DFS function will basically do the Dfs traversal, and let me just write the DFS code. Alright, so here is my DFS code, right? This is my DFS code. I am defining it before the function. I am defining it before. Now what will happen is, the moment I got that, okay, there is a house which has outgoing edge but which does not has an incoming edge. So there will be a DFS call on this, and whenever there will be a DFS call on this, it will come inside. If ith pipe ends at of W. Now what was the value of W? The value of W was 2 here, isn't it? So do you think the ith pipe end at 2 is equal to 0? No. Which means there is a pipe from here to the other house. So what we will do in that case? We will find out if the diameter of W, means this is 22, is less than the initial answer. Initial answer, you remember, we have declared some maximum value initially. You see, we have declared some very big number here initially. So we are basically checking if this value right now is less than the answer, then the answer will be initialized to 22 right now, because 22 is minimum as compared to this one. And then what will happen? I will be doing the DFS on the ith pipe ends at W, the next node of 2. So from 2, which is the next node it is connected to, 8. So there will be a DFS call on 8. The moment there is a DFS call on 8, what will happen? It will find out that 8 now does not have an outgoing edge, because you see, this condition will be met. Which condition will be met? You see, now there is a recursive call, isn't it? So recursive call, it will find out that ith pipe ends at of 8 is equal to 0. What does it indicate? It indicates the end of this particular component, and we will return W. So what did we return? We returned the value of 8. Fine. So we returned the value of 8. Now what is happening is basically, W means the ending point, right? The ending point of this particular component, and J is the starting point of the component. So the starting point of the component I am pushing in vector A, the ending point of that component of graph I am pushing at vector B, and the cost, the minimum path cost answer that we calculated was 22, was pushed in this vector answer. Got it? Next time what will happen? There will be a call on this particular node 3. When there will be a call on this particular node 3, what will happen? Again same thing. Let me erase this. Again there will be a basically, when I will be keeping on moving, and again when I will be J will be 3, J will be pointing to this node, basically this house, then this condition will be true, this condition will be true, because there is there is no incoming edge, but there is an outgoing edge. True. Again I will be declaring some maximum value to answer, and I will be doing a DFS call from node 3. The moment I do a DFS call from node 3, this node, okay, it will keep on doing the Dfs traversal and move on to the next node. And now the value of this edge is basically how much? 3 to 1 is 66 stored here, and 66 is less than this one. So for this particular component, the minimum answer will be 66. The moment I reach 1, what will happen? You remember this condition? The moment we reach 1, they will say ith pipe ends at 1 is equal to 0. Yes, because pipe 1 here is not sending pipe to any other room, basically any other house. So you will end here. It will return W, means you started at 3, ended at 1. So J value is 3, W value is 1. That is what we are going to store in the array, the resultant array, output array. So what we are going to push, J as 3 out, and the W value as 1, because this value will be returned by Dfs Traversal, the last node, and answer will be 66. So 3166, and before that we have found out 2822, right? 2822, and now finally the last time Dfs will be called will be for which particular node? This node 5. When you are at 5, again you will be doing a Dfs Traversal. So Dfs Traversal 5 will move to 9, 9 to 7, 7 to 4, 4 to 6, and the moment you move to 6, you will find out. Now you see, from 5 you moved 9, so 5 to 9, non-zero, so it will call 7, Dfs on 7. Dfs on 7 will take you to 4, Dfs on 4, Dfs on 4 will take you to 6, Dfs on 6 will take you to 0, and here you will end your Dfs. The last node is 6, so W will be 6, started at 5. What is the minimum cost in this path? For minimum cost in this path you will find 10. That will be pushed. So finally you saw how this particular thing is working, right? And this output will be pushed in these 3 arrays, right? Now let us just quickly compile and end this particular discussion. So I am using this cout function here to print out the resultant array, right? A.size, and basically A.size will indicate how many tanks will be required and taps will be required, and this J is basically indicating what? This is indicating our, this will basically print the outputs, right? Stored in the vector A, vector B, and vector C. So let us now compile this code. I hope we are not missing something. Okay, so this will not be integer here, only integer n comma p is fine. Sorry. Yeah. So let us now compile it. Alright, let us now compile it. So yeah, here it is, the output is fine. Now you can see basically whatever we had pushed, the results are produced here. 3 tanks and taps are required, and basically the vector A, vector B, vector C, the data that we have stored in vector A is this, vector B data is this, vector C data is this. So 2 to 8 there will be a pipe, length 22, 3 to 1 there will be a pipe, length 66, and 5 to 6 the shortest pipe length is 10. That's it. So that's all from this particular video. I hope this video was very helpful, intuitive. In case of any doubt, please feel free to put it out in the comment section. Just like, share and subscribe. And I would like to definitely try to come up with a more simpler way to produce this code. This is one of the code that was I basically found out in several articles. I just studied it, analyzed it, and tried to bring them in a very clear order. So I hope this will be helpful. Please support by liking, sharing and subscribing this. Thank you.